Okay, we're going to go over a few of the properties of logarithms today. You also have this um, note sheet. Let's see if I can find it here. This green colored or whatever color it is note sheet that has these properties listed on it, condensing and expanding, um, or properties that we will use to help condense and expand. All stuff that we did in Algebra 2. Just want a little practice with that before we start solving logarithmic equations and exponential equations. So we're going to start here with some expanding problems. And, I have here in the directions expand the expression. Your homework will say something like write as the sum or difference or even multiple of logarithms, which basically means to expand the expression. Because we're going to have one logarithm here become multiple logarithms, and as this thing expands throughout the problem. So some of the things we want to remember: multiplication within a logarithm becomes addition between, division within a logarithm becomes subtraction between, and then if we have a power within the power spot in our logarithm, so if our power here is taken to another exponent, we can bring that exponent down in front and multiply it to the logarithm. All right, let's take a look at here, example 1. We have multiplication. We also have that exponent, but the exponent is not on both the x and the y. If that exponent were out here, we would start by bringing it down in front. But because it's only on the y, we want to take care of that multiplication first and turn that into addition between two logarithms. So we're going to have the log of x plus the log of y cubed. Now that 3 is only on the y, we can bring it down in front of that log and have log of x plus 3 log, we don't need that 3 anymore because I brought it down, of y. So we expanded that, wrote it as the sum of two logarithms. First thing we have here that kind of sticks out is that division. Division becomes subtraction between. And as we do that, I'm going to change these roots into exponents. So remember, the nth root of a is the same as a to the 1 over n. That'll be helpful. So I'm going to change this division here into subtraction. So we're going to have log of x squared q to the 1/3 minus log of y t to the 1/2. Okay, make sure you don't just subtract between that stuff like this. You need to make it become the difference between two logarithms. Okay, so we need a log here and a log there. All right, so now we have multiplication between both those logarithms, or within both of those logarithms. So we're going to separate that and make it addition. And as we do, I'm going to bring all these exponents down in front of the log that they should be in front of. So the first one is going to be 2 log of x plus 1/3 log of q. So I'm bringing all those exponents down right away. I brought that 2 down, I brought the 1/3 down, and then minus, there's nothing on the y, so I'll just have log of y plus log, forgot to bring that 1/2 down, 1/2 log of t. When you expand, you don't want to have any exponents in the end, okay? You want to have just, you want to bring those exponents down as these multipliers in front. All right, one more thing I want you to notice here is this subtraction was happening on this entire logarithm, meaning this should either still be in parentheses like this, and then we'd have to distribute that negative through, or right away we could just make this minus in both spots right there. Okay, and you can take 2 steps to do that if you want. The more you get used to doing these, the more you kind of look ahead and say, hey, I can do this all at once, kind of like we brought those exponents down. And now we're going to be going in the opposite direction. We're going to be expanding. So condensing. So any time you're condensing, you want to bring exponents up within the logarithm. Okay, we want to bring these guys up. So this natural log of x is going to be natural log of x cubed once I bring that 3 up. I'm going to leave this as minus right now and just bring up a positive 1/2. Natural log of z to the 5th. And then what I'm going to do is, from left to right, take care of these guys. So first I'm going to take care of the division within. That subtraction between is going to become division within. So I'm going to have the natural log, and then I'm going to have division within that natural log. The natural log of this guy goes in the numerator, this guy goes in the denominator. This is still being added to the natural log of z to the 5th. Okay, now this is going to become multiplication within. So this is going to become 1 logarithm now, 1 natural log, and I'm going to have y cubed over y to the 1/5 times z to the 5th. So what I can do is just put that z to the 5th up in the numerator with my x cubed. And we have 1 logarithm. If, as you're doing this, you can actually evaluate any of these things, you would go ahead and evaluate it. For example, had this been an e here, and this would have been e to the 5th, we learned yesterday the property that tells us that this would just become actually a 5. And then this would have been 5x cubed over y to the 1/2. So at any time, if you can evaluate a logarithm without a calculator as you're expanding, get rid of some of the stuff I just did, then you want to go ahead and evaluate it, whether you're condensing or expanding. All right, so subtraction here is going to become division within. This addition is going to become multiplication within. I'm going to take care of that first. I'm going to bring this 1/2 up. I'm going to bring that 5 up. And then I also have multiplication right here. That will become multiplication within. So we're going to have natural log of y to the 1/2. And if you want to take 2 steps to do this, you could say plus the natural log of z to the 5th. But we know this is going to become multiplication within. So let's just call that z to the 5th right away. This is being subtracted. So I don't need the parentheses anymore because I condensed that stuff in the parentheses. But now I need to put this, actually in this step I'm also going to bring that 3 up. Why not? But now I'm going to have this as my numerator and this is my denominator, because this is going to become division within a logarithm. So it's going to be the natural log. I'm going to have division, x cubed over y to the 1/2, z to the 5th. And as we're doing this, we're not going to worry about rationalizing that, even though that is the square root of y. We are just working on our skills in condensing and expanding logarithms and then evaluating if we need to. Okay, last condensing problem here. I'm going to bring that 4/3 up onto the 27, going to bring that 2 up onto the 9. And as we do that, we can actually evaluate those things. So we just have some base b here. We're going to take 27 to the 4/3, and we're going to take 9 squared. So that one I know offhand, I'm going to say that's 81. And I'm going to come over here just in the margin here and remind us how we need to handle 27 to the 4/3. Remember, if you have a fractional exponent, the numerator is a power, the denominator is a root. So this is actually the cube root of 27, and then we're going to take it to the 4th power. So the cube root of 27 is 3. 3 to the 4th ends up being 81. So what we have here is log base b of 81 minus log base b of 81, which if we have something minus itself, we know that becomes 0. But I'm going to go one step further just to show another property of logarithms. I'm going to do that division. 81 over 81, that becomes 1. Okay, and again, if you wanted to stop right here and say this is 0, you could be done right there. But I just want to show you that if we were to condense this further and have a log base b of 1, no matter what b is, if you have a 1 right here, this logarithm must evaluate to 0, because that's what you would take any base to get 1. So in either way, we have 0 as our final answer. All right. Change of base. We've actually used this a couple times already as we were doing some of our application problems. So just a reminder, when you do the change of base, you can use either common or natural logs. You will have some homework that actually says write using only common logs, or the next set says write using only natural logs. That means use the change of base and use that type of logarithm. So what that means is I'm going to use common for this one, and I'm going to use natural for this one. Okay. So what that means is we can evaluate this logarithm by taking the log of this value over the log of that value. So we can use our calculator. I'm not talking about the little template that you have on your calculator. The newer calculators have little templates so you can type it in just like this. But one of the things you're going to need to know on college entrance exams, the ACT, is this change of base formula. So we do want you to get used to writing it this way. Even if you use the template, I don't care. This needs to be written on your paper. So we're going to have, I'm going to use that fraction template just so it looks nice, and go log of 5 over log of 7. 0.827. So we have approximately 0.827. I'm going to round to 10,000. Actually, I think in your homework I said round to the 1,000. So we're going to leave it like this. All right, and the next one, so this is actually what you would take 7 to get 5. So I'm just going to make sure that that answer makes sense. I'm going to say 7 to the second answer, and it should give me 5 when I hit enter. All right, so we know that that works. All right, so notice how I'm writing an equal sign right away, because this is a exact value. So my next one is going to be log of 8. It is an equal sign. It doesn't look very nice. Log of 8 over log of 0.4. Base always goes down in the basement. And this is going to be approximately, actually with this one, I'm sorry, I was going to use natural logs, wasn't I? And I want to do that just so it doesn't matter. You can use either one. You're going to get the correct answer. You're going to get what you take this to get this. So we're going to go, this time I'm not going to bother using the template. I'm just going to say the natural log of 8 divided by the natural log of 0.4. This should be negative 2.269. And that is the change of base formula.